Hey, let me introduce myself. My name is James Webb, and I'm an explorer. I'm here to share with you some of the incredible discoveries and images I've stumbled across through my travels. From galaxies millions of light years away to supernovae that can't be seen by the human eye, I've seen it all. Let me take you on a journey through the universe and show you the most amazing sights imaginable. Let's go. Before I start showing you what I've seen so far, have you seen this little asteroid that photobombed one of my pictures of the universe? The audacity! It's the smallest object I was able to see, almost the size of the Colosseum in Rome. I'll give the mic back to the narrator and let him explain to you all my achievements. Number 1. Deepest infrared view of the universe to date. The first thing Webb did was to provide astronomers with the most in-depth and sharpest infrared view of the far-flung universe yet. Its first deep field, the galaxy cluster S-MAX-0723, is full of thousands of galaxies, including the faintest objects ever observed in infrared. The telescope captured this image, which is approximately the size of a grain of sand held out at arm's length, of an incredibly small area of the vast universe. The combined mass of the galaxy cluster acts as a magnifying lens that amplifies more distant galaxies, some of which were seen when the universe was only a billion years old. This deep field, obtained from images taken from various wavelengths, took Webb's near-infrared camera, NIRCam, 12.5 hours to take, surpassing the longest time Hubble Space Telescope took to obtain its deepest field. Suck it, Hubble. Now let's talk science. This image displays the galaxy cluster S-MAX-0723 from 4.6 billion years ago, with many galaxies in front and behind the cluster. Researchers will be able to break down and analyze Webb's data to learn more about this cluster. Additionally, Webb's mid-infrared instrument, MIRI, also witnessed this field, observing mid-infrared light. Webb's NIRCam has produced the most detailed look at galaxies ever seen before, including their faint features like star clusters and diffused areas. The light coming from these galaxies has been traveling for billions of years before reaching us and going back to the time of the Big Bang. The wavelength of the visible light has been shifted to infrared, which Webb is designed to observe. After analyzing the data, researchers will be able to gain additional details like the galaxy's mass, age, origin, and components. The prominent arcs within the field is also seen. This is because the galaxy's cluster's powerful gravitational pull is bending the light from more distant galaxies behind it, like a magnifying glass distorting an image. Stars are also witnessed appearing brighter with noticeable diffraction spikes at shorter wavelengths. Webb's MIRI image provides a colorful and vivid image of the dust clouds, essential for star formation and life itself, with blue galaxies having fewer dust particles, red galaxies being overwhelmed with dust, and green galaxies having a mix of hydrocarbons and other elements. Very colorful and beautiful. I'm in awe. If this was only Webb's first picture, can you imagine how great the rest is going to be? Number 2. The atmosphere of WASP-96b, analyzed by the James Webb Space Telescope. Using its advanced design, NASA's James Webb Space Telescope has recorded the distant signature of water and evidence of clouds and haze in the atmosphere of an orbiting, puffy, hot gas giant around a distant star similar to our Sun. This is the most detailed observation of its kind to date and is a major milestone in the search to identify habitable planets beyond Earth. This exoplanet, named WASP-96b, located 1,150 light-years away in the constellation Phoenix, has a mass lower than half of Jupiter's and is much puffier than any planet in our solar system. Its temperature is over 1,000 degrees Fahrenheit, and it completes an orbital period of just 3.5 days around its star. This combination of factors makes WASP-96b an ideal target for atmospheric investigation. On June 21st, Webb's Near-Infrared Imager and Slitless Spectrograph, NIRSS, captured a light curve showing the overall dimming of starlight during the transit, and a transmission spectrum showing the brightness decrement of infrared wavelengths between 0.6 and 2.8 microns. Analysis of the spectrum showed the presence of water, haze, and clouds, which was unexpected from prior observations. The Webb telescope was able to detect color differences of a thousandth of a micron and brightness variations of a few hundred parts per million. This observation demonstrates Webb's extraordinary capabilities for exoplanet research. In the coming year, its spectroscopy will be used to survey several dozen planets from rocky worlds to giants, with a quarter of observation time allocated to exoplanet study. It is now clear that Webb has the power to analyze exoplanet atmospheres, including those of potentially habitable worlds, with remarkable precision. Number 3. Southern Ring Nebula. For the first time, NASA's James Webb Space Telescope has uncovered that the faint star at the core of this scene is covered in dust, following the release of gas and dust rings outwards for thousands of years. Webb's two cameras captured the newest image of NGC 3132, the Southern Ring Nebula, which is 2,500 light-years away. The unseen-before details of the two-star system in a tight orbit, seen in both Webb's near-infrared camera and mid-infrared instrument. When viewed face-on, the Southern Ring Nebula appears as shown in this observation. However, if it were rotated to be viewed edge-on, its three-dimensional shape would be more obvious. Two bowls placed at the base facing away from one another and joined at the middle by a large opening. The brighter star, in an early stage of its evolution, is likely to cast off a planetary nebula eventually. In the left image from near Cam, both stars can be seen, while the right image from MIRI reveals dust around the second star for the first time. As the two stars orbit one another, their brighter companion affects the appearance of the nebula, causing asymmetrical patterns due to their stirring of the gas and dust. This information allows astronomers to learn more about the mass loss history of the stars, as well as how their orbits are affecting the environment of the nebula. The dust and molecules released by the stars can travel for billions of years and potentially become part of a new star or planet before eventually dispersing into the nearby cosmos. Data collected with NIRCam shows thin beams of light surrounding the planetary nebula. The starlight from the central stars is visible in places where the gas and dust have gaps, similar to how sunlight can be seen shining through clouds. Studying a planetary nebula is like viewing a movie in slow motion, as these phenomena are visible for tens of thousands of years. Each shell expelled by the star enables researchers to examine the gas and dust within it in great detail. Number 4. Stephan's Quintet. NASA's James Webb Space Telescope captures Stephan's Quintet, a group of 5 galaxies, in a groundbreaking way. Webb's largest image to date, it covers 1/5 the area of the Moon and consists of over 150 million pixels and around 1,000 separate image files. Its infrared technology and high resolution offer unprecedented views of the galaxy, featuring sparkling star clusters, star-birth regions, and gravitationally induced tails of stars, gas, and dust. Impressive shock waves from one of the galaxies, NGC 7318b, are revealed as it passes through the other galaxies. This provides insight into how galactic interactions may have driven early galaxy evolution. Edouard Stephan discovered Stephan's Quintet in 1877, located in the constellation Pegasus. Although referred to as a quintet, only 4 of the galaxies are closely clustered together, with the 5th and leftmost galaxy, called NGC 7320, residing in the foreground. While NGC 7320 is located 40 million light-years from Earth, the other 4 galaxies, NGC 7317, NGC 7318a, NGC 7318b, and NGC 7319, are almost 290 million light-years away. This proximity provided astronomers the unique opportunity to study the merging and interactions between galaxies, processes fundamental to all galaxy evolution and rarely seen in so much detail. For example, star formation can be triggered in each other, and the gas in these galaxies can be disturbed. The topmost galaxy in the group, NGC 7319, is home to an active galactic nucleus, a supermassive black hole 24 million times the mass of the Sun. Its light energy output equates to 40 billion suns. To study this in greater depth, the near-infrared spectrograph, NIRSpec, and mid-infrared instrument, MIRI, were employed with the integral field units, IFUs, further providing scientists with a data cube of the galactic core's spectral features. Meanwhile, Webb was also able to resolve individual stars in NGC 7320, as well as its bright core, in addition to discovering a vast sea of distant background galaxies. Overall, the data collected by Webb can provide a wealth of valuable insight into the rate at which supermassive black holes feed and grow, star-forming regions, and emission from the dust. Together, the 5 galaxies of Stephan's Quintet make up Higgson Compact Group 92, HGC 92, which serves as an ideal laboratory for exploring the cosmic dance of merging galaxies. Number 5. Cosmic cliffs in the Carina Nebula. Using NASA's new James Webb Space Telescope, infrared light has been captured to uncover previously invisible areas of star birth in a young star-forming region called NGC 3324 in the Carina Nebula. Appearing as a landscape of craggy mountains and valleys speckled with stars, this region is known as the Cosmic Cliffs, and the tallest peaks in the image are around 7 light-years high. The blistering ultraviolet radiation from the young stars is eroding away the nebula's wall and creating dramatic pillars above the glowing gas. Additionally, hot gas and dust stream away from the region due to the relentless radiation, giving the appearance of steam rising from the celestial mountains. Webb is able to capture protostellar jets and individual stars completely hidden in visible light pictures, as well as address questions that have been difficult to answer when studying star formation. The data acquired from NGC 3324 will help us to understand what sparks star formation, what limits it, and the effect of star formation on giant clouds of gas and dust. Located roughly 7,600 light-years away, NGC 3324 was cataloged in 1826 by James Dunlop and resides in the constellation Carina. The Carina Nebula, which is where NGC 3324 can be found, contains the Keyhole Nebula and the active, unstable supergiant star Eta Carina. Number 6. Jupiter and its moon, Europa. NASA's James Webb Space Telescope has provided stunning new views of Jupiter, including a look at its iconic Great Red Spot and the surrounding moons, revealing details of our solar system in infrared vision. The telescope NIRCam instrument captured distinct bands encircling the planet, as well as the vast storm, appearing white due to the processing of the image. The startlingly clear image captured moons such as Europa, Tepe, and Matisse, the latter two of which can be seen to the left of the Great Red Spot, and even minor details like hazes and Jupiter's thin rings, making the results a pleasant surprise to scientists. Brian Haller of the Space Telescope Science Institute noted, "From the faintest, most distant observable galaxies to planets in our own cosmic backyard, the James Webb Space Telescope has the full grasp of what it can observe." The telescope's infrared capabilities provide a unique opportunity to monitor moons like Europa and Saturn's Enceladus for possible plumes spewing material, as well as giving scientists a never-before-seen of Jupiter's rings. According to Stephanie Millam, Webb's deputy project scientist at NASA's Goddard Space Flight Center, it's really exciting to think of the capability and opportunity that we have for observing these kinds of objects in our solar system. Number 7. GLASS-z11 and GLASS-z13, the two candidates for the most distinct known galaxies. Using the James Webb Space Telescope, astronomers examined the gigantic Abell 2744 galaxy cluster, which was acting as a gravitational lens to distort an image of more remote galaxies. Rohan Naidu's team from the Harvard-Smithsonian Center for Astrophysics identified two galaxies, GLASS-z11 and GLASS-z13, From initial data from the GRISM Lens Amplified Survey from Space, GLASS, the galaxies have a redshift of 11 and 13 respectively, which indicates that they existed about 13.4 billion years ago, approximately 400 million and 300 million years after the Big Bang. Though the redshifts were determined from the near-infrared camera NIRCam, a more detailed spectrum analysis employing the near-infrared spectrograph, NIRSpec, will be necessary to confirm them. To the astronomers' surprise, the two galaxies were found in a 50 square arc-minutes area of the sky. This abundance of luminous galaxies in the early universe signifies that they are more frequent than previously assumed. GLASS-z11 and GLASS-z13 are moderately small galaxies today, measuring between 3,000 to 4,500 light-years across and containing around 1 billion stars each. Nevertheless, they are large for their time. Additionally, the two galaxies display a spiral disk-like structure, a phenomenon which contradicts the usual clumpy structure of high redshift galaxies. Based on galaxies formation theory, GLASS-z11 and GLASS-z13 have presumably increased in size and become giant elliptical galaxies over the past 13.4 billion years, and presently lie about 32 billion light-years from us, too far for any telescope to observe. Number 8. NGC 628, the Phantom Galaxy. A stunning image from the James Webb Space Telescope shows the intricate details of the Phantom Galaxy M74 located in the constellation Pisces. Noted for its grand design spiral structure, M74 lies almost face-on to Earth, allowing Webb to observe its gas and dust filaments in the spiral arms that extend outwards from its nucleus. The absence of gas in its core gives a clear view of its nuclear star cluster. By studying the star formation of this galaxy located 32 million light-years away, the FANGS collaboration is using Webb's mid-infrared vision together with Hubble's ultraviolet and visible capabilities, as well as radio images from the Atacama Large Millimeter Submillimeter Array, ALMA, to gain a deeper understanding of M74. The thorough combination of data from a variety of telescopes across the electromagnetic spectrum provide astronomers with even more insight than Webb alone can generate. Number 9. Odd Cartwheel Galaxy in an unprecedented detail. NASA's James Webb Space Telescope has used its powerful infrared capabilities to uncover new details of the Cartwheel Galaxy. This rare cosmic sight, located 500 million light-years away, is the result of a collision between two galaxies. The image features two rings that expand outwards like ripples in a pond and reveals a vibrant star formation in the galaxy's outer ring. Webb's near-infrared camera uncovers many individual stars, as well as the difference between the smooth distribution of the older star populations and the clumpy shapes associated with the younger stars. The image paints a vivid new picture of how the Cartwheel Galaxy has changed over billions of years. Using MIRI data that appear red in the composite image, Webb sheds light on the finer details of the dust in the Cartwheel Galaxy. This image shows various hydrocarbons, chemical compounds, and silicate dust, similar to that found on Earth, present in the form of a series of spiraling spokes. Previous Hubble observations were able to detect the spokes in 2018, but the Webb image reveals them with much more clarity. Through this observation, it is clear that the Cartwheel is evolving, as it was once a normal spiral galaxy like the Milky Way before its collision. This image helps us understand the past and predict the future of the galaxy. Number 10. Jupiter and its auroras. NASA's James Webb Space Telescope has taken stunning new images of Jupiter, giving scientists further insights into the planet's inner life. Scientists help to process the data into the final images, which show auroras and hazes swirling around the poles of Jupiter, as well as the Great Red Spot, a storm so large it could swallow Earth. Jupiter boasts powerful storms, strong winds, dazzling auroras, and extreme temperatures and pressures, giving it an abundance of activity. The auroras at the north and south poles of Jupiter are visible in a composite of images taken by the near-infrared camera NIRCam of the Webb Observatory. To make the infrared light visible to the human eye, it has been mapped onto the visible spectrum, with redder colors representing the longest wavelengths and bluer colors representing the shortest wavelengths. Scientist and citizen scientist Judy Schmidt transformed the data from the observatory into the images. The standalone view of Jupiter highlights the auroras in the reddest filter and depicts the hazes swirling around the poles in yellows and greens, as well as light from a deeper main cloud in blues. Scientists have discovered that the Great Red Spot and the equatorial region of Jupiter have high-altitude hazes, while the north of the equator has dark ribbons with little cloud cover. The white spots and streaks are likely the tops of convective storms condensed in the high-altitude clouds. It is difficult to combine images of Jupiter into a single view due to its rapid rotation. Scientists must make digital adjustments to stack the images in order for them to make sense. Number 11. James Webb NIR plus Hubble Optical combined picture of pair of galaxies. Researchers were able to trace light emitted by the large elliptical galaxy on the left through the spiral galaxy on the right, thanks to the combination of data from the NASA ESA CSA James Webb Space Telescope and the NASA ESA Hubble Space Telescope. This picture of VV191 includes near-infrared light from the Webb and ultraviolet and visible light from Hubble, and it allowed the researchers to scrutinize the effects of interstellar dust in the spiral galaxy. By observing Webb's near-infrared data, we can observe the extended, dusty spiral arms of the galaxy in greater detail, giving the impression that they are overlapping with the central bulge of the bright white elliptical galaxy on the left. Even though the two galaxies are relatively close astronomically, there is no indication of them interacting. Pay attention to the backdrop. Just like other photographs taken by Webb, this image of VV191 reveals multiple galaxies located millions of light years away. For instance, two fuzzy spiral galaxies can be seen on the upper left side of the ellipsoid galaxy, appearing to have roughly the same size but showing distinct hues. It's hypothesized that one could be immersed in dust while the other is distant, though experts still need to acquire spectra to ascertain which one is which. Number 12. Star WR140 surrounded by strange concentric shells. In July, the highly anticipated James Webb Space Telescope, JWST, captured an awe-inspiring image of a distant Wolf-Rayet star, WR140, that had mysterious concentric rings radiating outward. Shared on Twitter by citizen scientist Judy Schmidt, the image sparked a flurry of comments and debate about the origin of these intriguing patterns. Mark McCaughrean of the JWST Science Working Group explored the possibility that this phenomena was due to the star's companion star sculpting dust into an odd yet regular shape. Ryan Lau, the principal investigator of the project, has since submitted a paper that is soon to be released, exploring more on this topic. Despite the bewilderment of the image, it serves as a reminder of the power of the $10 billion JWST, the most powerful observatory sent to space to date, which is renowned for its unique infrared vision. Number 13. The Pillars of Creation. The iconic Pillars of Creation can be seen in a highly detailed and vibrant landscape captured by NASA's James Webb Space Telescope. These columns of cool interstellar gas and dust, often semi-transparent in near-infrared light, are the perfect setting for new stars to form. By precisely counting the young stars that have burst out of the dense gas and dust clouds, researchers are able to investigate the processes of star formation over millions of years. These stars, represented by the brightest red orbs with diffraction spikes, produce supersonic jets and shocks that create glowing hydrogen molecules and wavy patterns, visible at the edges of some pillars. Much of the deeper universe is hidden behind the interstellar medium, a mix of gas and dust in the densest part of the Milky Way galaxy's disk. The scene revisited by Hubble in 1995 and 2014, as well as other advanced observatories, reveals more details about this star-filled region 6,500 light-years away in the Eagle Nebula. Number 15. WASP 39b Atmosphere Update. Observations of WASP 39b with the James Webb Space Telescope have revealed a detailed chemical composition of the exoplanet's atmosphere, including the first discovery of a photochemical reaction product. Scientists have identified the mystery molecule as sulfur dioxide, produced through photochemical reactions from light from the planet's host star, similarly to the formation of ozone in Earth's atmosphere. The findings indicate a history of smash-ups and mergers of planetesimals, as well as evidence for patchy clouds in the atmosphere. The data from the 4 transits of WASP 39b, gathered from 3 different instruments on JWST, provides a comprehensive view of the radiation process between the host star and the planet. Number 16. Planet-forming disk of dust surrounding a small young star, AU Mike. Observing the red dwarf star AU Microscopii, or AU Mike, in the constellation Microscopium, located 32 light-years away, NASA's James Webb Space Telescope, Webb, has provided a glimpse back into the history of the system. With Webb's highly sensitive and powerful infrared instruments, the study's lead author, Kellen Lawson of NASA's Goddard Space Flight Center in Maryland, was able to directly observe a large and extremely dusty debris disk surrounding AU Mike. This disk is a remnant of the formation of AU Mike, likely containing planetesimals, the leftovers of the formation of planets. Her team observed at wavelengths of 3.56 and 4.44 microns. The images of the system, approximately 23 million years old, have a blue appearance due to the high amount of fine dust that scatters light at shorter wavelengths. Moreover, the use of Webb's near-infrared camera and coronagraph allowed them to trace the disk to within 5 astronomical units of the star. The study's primary goal is to search and characterize gas giant exoplanets in wide orbits, and the results have made it possible to directly observe these exoplanets around their host star. Number 17. Webb Spectra confirms 2 arcs are the same galaxy, NIRSS emission spectra. Let's go on an intergalactic treasure hunt with the NASA ESA Webb Telescope. The near-infrared image of galaxy cluster SMACS 0723 reveals a group of massive galaxies below and to the right of the bright central star, with numerous distorted and magnified galaxies. Upon inspection, one arc appears to be composed of 2 similar-looking galaxies. Are they the same? Spectra from the near-infrared imager and slitless spectrograph NIRSS helps researchers answer this. By plotting the spectra from each of the 2 galaxies, the graphs match, which suggests that the arcs are identical and both were emitted 9.3 billion years ago. NIRSS's ability to spread out the spectra reveals which lines match which source. Who knows what discoveries await as researchers use NIRSS to turn every object's image into spectra? Let us know what your guesses are. Number 18. Webb Spectra identifies galaxies in the very early universe, NIRSpec MSA emission spectra. Using the near-infrared spectrograph's NIRSpec microshutter array, the Webb telescope has made another incredible discovery. It never stops, does it? This instrument has over 248,000 small doors, each of which can be opened to measure light from up to 150 separate objects at once. By looking at the 48 galaxies in the background of the galaxy cluster SMACS 0723, researchers were able to see distant galaxies in the early universe, estimated to be 13.8 billion years old. These spectra prove useful in that they show a pattern of 3 lines in the same order: 1 hydrogen line, followed by 2 ionized oxygen lines, which gives a measure of each galaxy's redshift, and therefore how long ago the light was emitted. The farthest galaxy observed was determined to be 13.1 billion years old, which is believed to be the first time these emission lines were seen at such a large distance. It is also believed that there may be more distant galaxies hiding within this image. Using Webb's data, astronomers can pinpoint the distance, temperature, gas density, and chemical composition of each observed galaxy. On top of that, Webb provides high-resolution near-infrared light information, far from the filtering of Earth's atmosphere. Comparing these spectra with those of nearer galaxies observed by both ground and space-based observatories, scientists can understand how galaxies have changed over billions of years, beginning at the early universe. Thank you very much for watching this video. We hope you enjoyed and learned something new. Stay tuned for more videos, and don't forget to like and subscribe to watch our videos.